Happy Sunday, everyone! I'm back for this bar schedule for Beam or cutting list gihapon siya for Beam. Thank you, by the way, to Inside Iya aning Engineers Corner. So, siya po ang nag-comment and nag-request of cutting list sa beams and columns. Thank you so much sa idea. And hopefully, makatabang ni siya or this is what you expect or ma-meet ani nga video ang imong i-expect nga cutting list for beams. So, let's start. Again, let's get back here in the format of our Excel file. I just changed it from column to beam. And then the same, we have main bar and lateral ties. No, this is not lateral ties anymore because this is for columns. So for beams, they should be stirrups. I'm glad I noticed that. And so, delete mo po muna yan. I noticed also that we have subscribers here that are not Filipinos. Thank you so much. Guys, di mo na ko maisa-isa. I can mention all of you. So thank you for subscribing and for spending your time here, learning here. Thank you guys. Hopefully I can help you through these videos. So I will try to speak in English, but if I can't, oh please, I will speak in my dialect. So here we have the schedule for reinforcing steel bars. So the same format. I just changed this here. Usually this is total. This is just total here like that. But I just put it like this to indicate that this is just total for one beam only. So we will just estimate for one beam today. So I have to minimize this and let's get back here. And I will show you the details I get from the plan. So here we have, this is it. So roof beam. I cut it out from a whole plan. So you can see this in the detail of roof beam or the beams details. So this is just a low-rise building. So this is what it looks like. And usually this is not reflected here. Just this two. This cross section here, typical cross section here is for the middle. They forgot to put it here. This should be for at mid-span. So you can see at mid-span here in this portion. And this is the detail, reinforcing details for here at support. You can read it in a complete plan at support. At support din to. Usually this is not reflected because this is just the same as this one. Just reflection of here. It's the same. So at support. This is the installation or the details of how you put the reinforcing bars in this section. But as you can see, because this is just a simple roof beam, so they are just the same. Usually in the other beams or bigger beams, we have example 3 here and then 3 in this bottom part and then 3 again here. But let's just focus in this example, okay? The purpose of this video is to get the hang of how to estimate the beam. Yeah, the reinforcing in the beam and what it looks like in the cutting list. Okay, as I've mentioned in the other videos in columns, this portion here, the cutting list. This is where the steelman should check on how they have to bend the bars, okay? Or usually cutting list is just in bigger construction. On small construction they don't have like this, so steelman should also know how to read a plan, or if not, you can always ask your foreman or the engineer. Okay, so this is where you watch steelman. And then let's go back to here. So let's start I will minimize this in this Excel file. Okay, for our schedule of bars, we have to estimate first the main bars. So main bars, gagawin mo na lang yung main bars kasi madami naman sila. Okay, main bars, we have, as we can see, ma-maximize ko lang, sabi dito, 2 that's 12 mm diameter bars. This is a sign of diameter. Okay, 2. So meaning, dalawang 12 mm. You can see this is for main bars. So this 1 and this 2. And here at the bottom bars, these 2. Okay? So they are just the same at mid-span here. Diba? The same. It's the same. So our beam is 200 mm by 250 mm or 0.20 meter and 0.25 meter in depth. Am I pronouncing it correctly? So overall, we have, for our main bars, we have 4. Because it's the same at mid-span, it means that our main bars runs from support going to the other support. Okay, so there is no bending down here because there's no extra bar. So these 4 are main bars. It's a simple roof beam. And it is not reflected here, but the actual construction, we have here the hook. We have to put a hook here and the bottom part also. So gagawin natin dyan. It's like this. So I have prepared the cutting, the bar bending. You can see this is for the main bars. So the bar size is, you remember, it's 12 mm, and the spacing, they did not reflect the spacing because it says 2. So you just have to put this as shown. Because it's already indicated that it's 4. So bar type, I just designated it in the bar bending, or if the plan has already a bar bending diagram, so just look there and check if what's the bar type. Okay, but for this example, we have A, so A, capital letter A. So now we have to start to how we bend our RSB. So this is how we bend it. Okay, from support to the whole stretch of the beam and then support. We bend, it's hooked and at support here also. So we designated it as small letter A, B, and C. It means that here we need the length or the measurement of small letter A in meters. Okay, remember that, or check here if what's the unit. It's in meters, so ABC. So A, how long is small letter A? So how long is our hook? Okay, so you can check that on the general notes. So let's try 12D. 12 times diameter, which is the 12 mm, means 144 mm. This is mm. So if 144 mm divide 1000 mm becomes 0.144 meter. Or we can round it up to 0.15 or 150 mm or 0.15 meter. And then for our small letter B, how long is this small letter B? Let's go back to the roof beam detail. We have 5 meters. Okay, we have 5 meters center to center, so we can just use this 5 meters. Okay, 5 meters, and then C is just the same with A. Okay, equal nyo lang yan. You just put equal and then that's it. Okay, and the other D, E, F, G, H, this here, just leave it blank if it's not necessary. We only have here ABC. So for splicing, you have to check this. So the total is, we have to answer this first, the length. We can input equal sum, then open parentheses from A, drag up to splicing. Okay, up to splicing, it's L. and then close parenthesis, so 5.3. So since our commercial length or the available length of our RSB in the hardware is 6 meters, so 5.3 is within 6 meters, right? So we don't need splicing. Hopefully by now, we have already so many videos here, so hopefully by now you know what the splicing means. So let's leave it 0 there. And then the quantity, so how many main bars do we have? So in the plans, we have 4. The bottom and the top bars is 4. So the total is calculated. Well, again, let's calculate. So equals 4 times 5.3, it's 21.20 meters. Yung total na main bar sa isang roof beam. Okay, unit weight. Unit weight is the weight of reinforcing bars in 1 meter. So this is 0.888. Naka-formula na to that if we change this, it will change. 10 mm, it's this. So again, 12, it's 0.888 kilograms per meter. Also check that on Google. So total weight for our grade 40, so kilograms. So since this is 12 mm, and let's use grade 40, so let's just multiply this unit weight times total length, di ba? Meter times kilogram per meter. So meter is cancelled out. What's left is kilogram times this 18.83 kilograms. So this is not grade 40, so leave it blank. Then let's proceed to the stirrup. The details of the stirrups is not usually found here because this is just for the main bars. Somewhere here, it will point out. So this is our stirrups. So this is it. It says use 10 mm stirrup space at, diba? It's the same in column. We also have 2 spaced at 50 mm, 4 spaced at 100 mm, and the rest is spaced at 200 mm. So how do we count how many stirrups are there in this one roof beam? So what we do is we need to get the distance of this. Let's do the editing so that we can add. So we need to know the clear distance of our beam. Diba? Hopefully you also know already. I know you already know what's a clear distance. So, okay, that's that. So clear distance from here. So it's not in the dimension of our columns is not. Oh, I see. This example is showing the beam here. It's not the column. So it means this 5 meters is the clear distance already. Okay, so this is where the column started here. So the column here and there columns. My column is so straight. So this is already our clear distance, 5 meters. So 5 meters, we have first to put the bars. I will have to save this. And then, so bars is 10 mm. I will put 10 mm here because they all have. And we separate this into the same way the column, what we did in the column. So the spacing, we have to separate to 50. Although you don't have to separate that. But for this example, we just have to separate to make it easier. Okay. So 100 and 200. It's in mm. Okay. In the column, we use that as meter. So let's just use again here in mm. So bar type. So for our bar type, let's go back in our bar bending diagram. It's bar type B. Okay, B. Okay. And then for our bar bending. So usually, I always make this here as A so that I will go in this flow. A, B, C, D, E, then F. Like that. So, F hanggang F. Until here, F. So, how long is our A? So, you have you remembered the hook formula in the general notes we used last time, although you didn't have to use that all the time, you have always look or check, always check the general notes in the plan you are using. Okay, but if not found, you can always use the 6 day. 6 day or 63 mm, whichever is higher. So let's find out 10, 10 mm times 6 is 60. But 60 is less than 63 mm, so whichever is higher, so 63 mm. We use 63 mm, that's 0.063 meter because remember we're using meter here. And then B, how long is this B? So B is this. Our beam is zero point 0.2 and 0.25 for the depth. Our B is here, 0.20 meter. But we have, if this is 0.20, 0.20, we need to, this is our B here, just here. So we have concrete cover. I mean, this is our concrete cover. For beam, what is the minimum concrete cover? It is at least, okay, at least 25 mm. Okay, also here 25 mm. So for this 0.20 meter, 0.20 meter, we have to subtract the 25 mm from this side and this side also. So B equals 0.20 minus 25 mm is 0.025 minus 0.025 meter for this side and this side. So it's 0.15. And then for our C is here. So here again here. So we also have to calculate this in the same manner, but we have to change in our depth is 0.25 meter minus here 25 mm and this here is 25 mm, or no, this is 0.25 meter minus 0.025 meter minus 0.025 meter. I converted this already, okay? This 25 mm or 0.025 meter. So this is it. So our D, let's get back here. D is equal to B because this is just rectangle, right? So we can just D equals B and then E equals C. Okay, hope you follow. And then F is just equal to A. So you just have to equal and then that's it. And so we're done with that. We just need to length. So the length, you can just control C and control V. Okay, copy paste nyo lang yan. Or we can just do all over again, equals sum, and then open parenthesis from A drag down to splicing, and close parenthesis. No, it's the same. So for quantity now because this is all the same stirrups, the same size of stirrups, we can also copy this, control C and control V. Okay, because this are the same, but we separate them because of their spacing. So quantity. Wow. Let's get back to the details. So here it says 250 mm. So we can put this here 2, right? But 2 means just here in this side. How about in this side, right? So this is 2 times 2. Okay. And then the 100 mm is 4. 4 times 4. 2, I mean. 2. 4 times 2. Only 4 times 2 because 4 here. 1, 2, 3, 4. And then 4 here as well. 1, 2, 3, 4. By the way, you can also just count this here, but usually or sometimes the plan is not really scaled or it's not really quantified according to how many stirrups are there, because sometimes the plan is they just and sometimes they just copy paste. So let's not rely on the details. We need to estimate it, okay, according to the to what's specified here. So we're done with the 4, that's 100. So 4 and 4 is 8. So for the spacing if of 200, we need that how many in this middle section, right? So what we need to do, usually this is how I estimate the beam, equals the 5 meters divide 2. I will estimate the half of the beam. Okay? Because the other part or the half also is just it's just the same with the other half, right? So I will estimate just the half of the beam. So 5 divide 2. And then I will subtract the 50 mm times 2, right? I am using the half of the beam. So times 0.001, so that this 50 mm becomes meter, and then minus this 100 mm times 4, right? 4, and then multiply by 0.001 to make it meter again. And then I have to place ice here, ice here, ice here. After the equals, I will add an open parenthesis, another one open parenthesis. Okay, and then here at the end, another close parenthesis, and then I will divide it with 200 mm. So 200 mm is in meter, so I will have to open parenthesis 200 mm times 0.001 to make it meter, and this. So this is the quantity or the quantity of the stirrups in half of the beam, for half of the beam. 10 pieces at 200 mm space. So because this is just half, so we can multiply it by 2. Okay, multiply by 2. So this is it. So total length again is just equals quantity times the length. So that's it. And you can just drag down there. And then, so the unit weight for 10 mm is this. So total weight it's 10 mm. So it's grade 40. So equals this unit weight times the total length. Okay, that's it. And you can just drag down or copy, paste. That's it. So here is already the total of this grade 40. Okay, so this is the total for the total RSB or the total weight of RSB for one beam only. Okay, and this is not for all types of beams. Remember, please remember, this is just for this example in this dimension and this, yeah, in this length and this dimension here, for this, just for this example, unless you are estimating the same. Okay, so this is it. So we need the volume of the concrete. So the volume of the concrete is just here. Our beam is 0.20 meter. So as you can see, I did not input equal sign, but and the meter, the unit meter, but it appears because I already programmed it this way. So that is times the depth 0.25. That's it. and times the length, the 5 meters, and how many beam? It's just 1. So, multiply, multiply nyo lang yan, and that's it. 0.25 cubic meter. So, we're done. And thank you guys. Happy Sunday. Thank you for watching.